Hello friends, welcome back to my channel. In this video, we will discuss about some of the important electrical parameters in electrical power system. Okay, let us discuss. Before going to study about the economical parameters, first we can discuss about load curve. As the name indicates, curve, it is clear that it is a graphical representation of load with respect to time. In this graph, you can see the graphical representation of load with respect to time. In this axis, load is represented in megawatt, and here the load corresponding to time. Okay. In this graph, it is clear that the midnight load is, some load will be there and like this. And the time from 2 a.m. or 4 a.m. the load in the station will start increasing. You can see that at the time of 6, between this 6 and 8, almost it is 7 a.m. in the morning. So at that time, almost most of the machineries in the particular plant are operating in its maximum range. And we know that in our house, almost in every house, most of the electrical equipments or light, mixie and some kinds of electrical equipments will work in this period. Okay, so the load in that period will be higher, and when coming to 10 a.m. or 11 a.m. in the morning, it will decreases, the load will decreases. And at the noon time, after this noon time, the load again will starts increases, and at 6 p.m. in the evening, you can see that at the evening time, this load will be maximum, and it will decreases drastically after 10 p.m. Okay, this is very clear representation for the use of load with respect to time. You can, I think it is very clear for you. Okay, so the load curve will shows the variation of load on the power station. So from this graph, it is very clear that load in the power station is not same for all time. It will changes as per the need of use. So it will changes time to time. When the load curve is plotted for 24 hours in a day, then it is called daily load curve. Here you can see a daily load curve because it is plotted between 10 a.m. to 10 p.m. So it is daily load curve. When the load is plotted in month, then it is monthly load curve. If it is 1 year, then it is annual load curve or yearly load curve. So load curves can be different types based on the period of usage. Okay. Area under the load curve will represent the number of units generated in a day. It is, you can easily observe from the graph. Here you can see daily industrial load curve. Load curves can be different types, but here I plotted only two types of load curves. Here you can see daily industrial load curve. Here in this axis, load is represented in kilowatt, and here hours. It is an industrial load. So in industry, from 6 a.m. it will starts to increase and will be peak. Continuously it will work from in the morning to the noon time. So it will be maximum at this period. Industrial load curve will be constant from the morning to noon time, and this is lunch break time. So most of the machineries will off at this time. Not all, but some of the machineries. Okay, and after this break time, it will again starts and will be maximum for some times like 6 p.m. or 7 or 8 p.m. and after that it will drastically decreases, and some of the machineries will works 24 hours. So that will indicated by this region. So it is the graphical representation for daily industrial load curve. And in this picture you can see the residential load curve in for winter and summer period. Okay, it is very clear that already we discussed about this case in the second slide. Okay, so from the 6 a.m. in the morning, the load on the station, load on most of the houses will increases, and it will decreases at the noon time, and again in the evening it will decreases drastically, and 6 p.m. it will increases like this. During the summer period, some additional equipments will works most of the time than that of the winter period, like AC, fan, like that. So the graph, the peak value or the peak ranges of the load curve for summer season will be higher than that of the winter season due to the usage of the electrical equipments. So the graph will be very peak at that night period, and after 10 p.m. or 11 p.m. in the night it will drastically decreases and will be like this. So this will represents the residential load curve. Now let us discuss about two types of loads. One is base load and the other one is peak load. From this name it is very clear for you. Base load is nothing but it will works 24 hours in a day. It is a minimum level of electricity demand required over a period of 24 hours. So it is also referred as continuous load. Okay, this is the graphical representation for base load and peak load. This blue colored portion will represent base load. That means it is the minimum level of electricity, it will always be there. So it is referred as continuous load. And the generating plants works 24 hours in a day, or 30 days in a month, or 365 days in a year is referred as base load plants. So we will discuss about them in the coming slides. And the next type of load, that is peak load. It is the time of high demand. So the peaking at the, so this peak load will operate, or it will be the loads only for short durations. In the load curve already we discussed, in the morning time 6 a.m. to 10 a.m. or 11 a.m. the load will be maximum, and it will drastically decreases, and finally after 6 p.m. it will increases up to 10 p.m. or 11 p.m. So at that, during that peak periods, some of the loads will be there. So that is the peak loads. And some of the loads will be there, intermediate base loads, that can be base load or intermediate loads. Sorry, or peak loads. It can, intermediate loads can be both base load or peak load. So that is a major points about base load or peak loads. Now let us discuss about base load power plants. We know that base load means that will provide loads during a given period of time. That is, that will working continuously. So they are known as continuous loads. So here the plants which are running continuously over a period of time, that is base load power plants. And some of the power plants are categorized under this load, and the others are in peak load power plants, because Some plants need long time for their starting and the less availability of fuel. These are the major reasons. So the baseload plants are mainly categorized as nuclear power plants, coal power plants, hydroelectric plants, geothermal plants, biogas plants, biomass plants, solar thermal plants, ocean thermal plants. These are the major baseload plants. But this hydroelectric plants can operate as the base load if plenty of water is available in the reservoir. If it is not, then we can operate it as the peak load plants. But for technical exams, this question is very important, that hydroelectric plants are categorized under this base load power plants. This point is very important. Next is about peak load plants. Peak load plants are the plants which are operates under the peak load times. So mainly they are gas power plants, solar power plants, wind turbines and diesel generators. Normally in technical exams this question is important. Many times we can say this question, that is diesel generators diesel generating power plants are coming under this peak load plants. Okay. Now let us discuss about the economical parameters. The first parameter, that is connected load. Connected load. Okay. It is nothing but the sum of all individual loads connected to the supply system in kilowatt hour. This is very important. So in kilowatt hour. We know that in our house there are number of lights, fans and some other electrical equipments will be there, and we can calculate the connected load in our house. We can calculate the connected load means the sum of all points which is connected to the supply system. That is the connected load of our home. So connected load can be equal to the number of lights into kilowatt plus number of fan points into kilowatt plus number of water heaters into kilowatt plus etc. plus etc. So in this way we can calculate the total connected load in our home or in a particular industry or in any plants or something like that. So connected load is the total load or the sum of the individual loads. Next is maximum demand. It is the greatest of all short time interval averaged in a particular period of time. That can be 15 minutes, half an hour, 1 hour or something like that. The maximum demand is mainly provided by the electricity providers. And the maximum demand can be calculated in 15 minutes or half hour or whatever it is, that is mainly decided by the electricity suppliers. Most of the states in India it is half hour. Half hour maximum demand is measured in, and it is measured in generating stations by using this maximum demand meter. And a peak operating load or maximum load in kilowatt of the consumer for the specific interval is divided by the operating power factor. In this way we can calculate the maximum demand. So maximum demand, it is measured in kVA and that is equal to peak load in kilowatts divided by power factor. In this way we will get the maximum demand. And based on this we can solve a problem. If running 5 numbers of 5.5 kilowatt motors at 90% of the load with 0.86 power factor, then calculate the maximum demand. So we need to calculate the maximum demand, and these data are given here. So we know that maximum demand is equal to peak load in kilowatts divided by power factor. So we need to calculate the peak load in kilowatt. So peak load in kilowatt, we will get, here it is 5 numbers of 5.5 kilowatt motors with 90 percentage of the load. So peak load is equal to 5 into 5.5 into zero point 0.9 is equal to 24.75 kilowatt. That is the peak load in this question. So maximum demand is equal to peak load divided by power factor. Power factor is given as 0.86. So after calculation we will get maximum demand is equal to 28.77 kVA. That is the maximum demand of this problem. Next factor, that is demand factor. Demand factor is nothing but the ratio of actual maximum demand of the system to the total rated load connected to the system. So in the consumer's end, demand factor is equal to maximum demand divided by connected load in the consumer end. And for power plants, demand factor is equal to maximum demand divided by installed capacity. And its value is always less than 1 because the connected load will be higher than that of the maximum demand. And the installed capacity will be always higher than that of the maximum demand. So that its value, the demand factor will be always less than 1 and it is measured in kilowatt or kVA. So this point is very important, that is the demand factor is always less than unity. Okay. The next economical parameter, that is average load or average demand. That is the average of loads occurring in a given period. That can be daily average load or monthly average load or annual average load. So we can calculate the daily average load is equal to kilowatt hour supplied in a day divided by 24 hours. If we are going to calculate the monthly average load, then we can calculate it by using this equation, that is kWh supplied in a month divided by 24 into 30 days into 24 hours. Similarly, we can calculate the annual average load, that is equal to kilowatt hour supplied in a year divided by 24 into 365 days. So this equation, by using these equations we can calculate the average load for the given period of time. Okay. Next is load factor. Load factor is nothing but the ratio of average demand to the maximum demand. Or we can also define the load curve is equal to the number of units actually generated in a given period of time divided by the product of maximum demand to the number of hours for the operation within a given period. These two equations can remember for the solution of problems based on this economical parameters, and its value is always less than 1. This point is also very important for technical exams. And one more point is that if the load factor is higher, then lesser will be the cost per unit generated. That means if the load factor is higher means maximum demand is very less. That is the good condition for the lesser cost for the production of units. Next is diversity factor. That is nothing but the sum of individual maximum demands divided by maximum demand of the power station. And it is always greater than 1 because the sum of individual maximum demands will be very higher than that of the maximum demand of the power station. So its value is greater than 1, and this point is also important for technical exams. And remember that if the diversity factor is very high, then the lesser will be the cost of generation, because that means maximum demand of the power station will be lesser. And the next point is coincidence factor. That is nothing but the just the reciprocal of this diversity factor, and that is always less than unity. Next important parameter, that is plant capacity factor. Plant capacity factor is nothing but the ratio of average demand to the installed capacity of the power plant. Installed capacity of the power plant. Okay. And that is that can also be defined as the energy generated in a given period. That can be in a month, yearly, or in a day, divided by the installed capacity into number of working hours in a given period. Okay. These two equations are very important for solving the problems. And this plant capacity factor is an indication for the reserve capacity of the plant. Okay. The next point is plant use factor. It is nothing but the ratio of annual energy generation to the product of installed capacity of the plants into the number of operating hours. The 10th point is plant availability factor. That is the ratio of capacity availability to the installed capacity of the power plant. The last point is the reserve capacity factor. That is nothing but the ratio of reserve capacity to the installed capacity. And reserve capacity is the capacity availability minus maximum demand. Okay, these are the major economical parameters, and these are some simple problems will be there for most of the technical exams. We can see that. So these are the major factors or the equations based on this plan use factor. I think these equations are enough to know about this economical parameters. Okay, I think it is helpful for you, and thank you.